Okay, so last minute this morning, I decided to not really focus on new content today. And this will allow people who really want to focus on APE and APE prep to be able to do so. On the other hand, we're going to be tackling another Project Euler problem. For those of you who are not going to be focusing on the APE, it's perfectly okay if you would like to do that focus. But I do think that this logic and development of an application that solves this problem will help with your general programming and applying skills and debugging. And this will again involve reading stuff in from a file. So this problem is going to have us look at this 20 by 20 grid. And last time we were trying to find the 13 adjacent numbers that multiply together to create the largest product. And now we only are looking at 4 numbers instead of 13, but they can appear horizontally, vertically, or diagonally in this associated grid. So we want to find the 4 numbers that do this. Now, whenever I do this, I'm very, very curious if people can spot the solution. So I'm going to give people 30 seconds. Where is it? The 4 adjacent numbers, horizontally, vertically, or diagonally, that have the largest product. Go.
What? Diagonal, horizontally,
Any direction.
Uh-oh.
Anyone think they found it?
Yeah. 94, 95, 72.
Incorrect.
What about 87, 97, 94, 89?
Actually right. You found it. That's good. So we're going to write a program that is going to go find exactly that. That was good. That was really good. I will once we write the program for it. I've only done this 3 times, I think. I did it once at Millersville, once last quarter in this class, and once this quarter, and no one's ever found it in 30 seconds. Nicely done.
Read the numbers from here. I'm not running my class.
That's fair. That's absolutely fair. But it's a first time for everything, and I love that. So how would we go about doing this? We're going to just copy and paste this into a text file, just like we did last time. We need to figure out how we're going to read this in, and now we need some structure that is going to allow us to be able to search this horizontally, vertically, and diagonally, and not consider things that are out of bounds. Like for instance, if we are right here and we try to read diagonally down left, we're going to end up out of bounds. If we're right here and we try to read horizontally to the right, we're not going to be able to do so. We're going to end up out of bounds. So we need some logic to make sure that we are staying in bounds, only considering cases that are in bounds, or aborting the logic as we figure out that we are now out of bounds. So think about that for a little bit, see if you can come up with a reasonable outlined solution. As always, don't get started programming right away. Come up with a design. Think intuitively about how should I be solving this problem? What makes sense? How can I break this down into subcomponents? And then create names for those subcomponents. Those will probably end up being your methods. And then focus on each one of those subproblems one at a time. that people have had a little time to think. What underlying structure do we think we want to use to store this?
A string array.
String array, an array of strings?
I was thinking go to array, but setting up would be complicated.
Yeah,
I was thinking to see if we can store it by, array that is 4 by 4. To kind of chop out like each 4 by 4 from. the
okay,
top.
so yeah, like you have fours. But what about the overlap between some of those? Like you could start. The first thing you might need to consider is 8, 2, 22, 97. Then we just think about 2, 22, 97, 38. We can't just necessarily take blocks like that. That's a good idea.
My thought process was to put each line into its own array list, or not an array list, into a regular list. And then also do it for every column. And basically have it so that the first one always gets the bottom. The first one of every column gets the 4 below it, or the 3 below it. The second of the next row, the third of the next row, and the fourth of the next row,
Interesting.
and just have a very complicated mess.
I think we can make this a little bit easier than this. So how are we going to figure out every possibility of every possible sequence of 4? If we could just highlight this 8, what are all of the possible sequences of 4 that contain this 8?
There's only 2. You got 2 lines?
3, should be 3.
Alright, 3.
We want to think this way. We want to think this way. We want to think this way. Is there one other consideration that we should have in general that we don't have here?
The other diagonal.
The other diagonal, like down left? Yeah.
You can do like 8 different directions depending on where you are in the grid.
There are 8 different directions, but we only need to consider 4 of them. Why?
Because as we go down the list, we already checked the diagonal.
Yeah, by the time we hit this
We went to
97,
a diagonal.
we've already checked left. By the time we hit this 23, we've already checked up left. By the time we hit this 52, we've already checked up. So we only need to consider 4 directions. Now, it can't be any 4 directions. If we do this as a circle, we would want the 4 directions to be adjacent, but there's no wrong way to do this. You can, instead of doing this, do that instead. So as long as you have 4 directions that are adjacent to each other in a circle, you would be fine. So I'm gonna focus on these 4 because they're the ones that make the most sense starting from the top left. But if we started from the bottom right, for instance, which we could theoretically try to do, that might be a little tricky. You could recursively start filling a structure from the bottom right up. Makes it harder than it needs to be for no reason. So that's gonna allow us to do this. We check those 4 things. We store the largest product of those 4. We need to check and make sure that each of these directions are in bounds, because in this case, this down left is out of bounds. Once we check all of those 4, we can move on from the 0, 8. What's the next number we should consider? Two. We can then check again to the left, to the down right, 1, 2, 3, 4, to the down, and to the down left. One of those is out of bounds. But those are going to be different products than the last one, but they all start with the 0, 2. We could loop and do this process for every number in this table, checking its left, down right, down, and down left. We store the largest product that we've seen so far as we do that, and every time we come up with a new one, we check, is it bigger than the largest product that I've seen so far? Now, the issue is, we don't care about what the largest product is, we care about where it is. We want to be able to identify it. So what we need to do is we need to store the row and column that started the solution, and then we need to store which direction we looked when we found it. So whenever we replace the largest product seen so far, we want to store the current row and column where we are, and we want to store the direction that we looked. I'm just gonna leave that up there for a bit as you figure out how you want to move forward. Check, let's make sure I don't have anyone in Zoom. In this classroom, it doesn't notify me apparently. I have nobody in Zoom.
So if you're gonna start from the left, so if you're gonna start from a number 8, and then you're gonna start going right, and then this way, and then down, and then this way. If you can name each of these, like 1, 2, 3, 4, and then when we find the highest product, we will attach that number 4 with it.
Yeah,
So we know which direction. it's going.
exactly. You could even do a quick conversion of if it's 4, then print down right. Or something where the output is easy to read, even though internally you're storing it as just an integer. You can even do it as an enum and just say that you have those 3 things. And since we know that an enum underneath the hood is 0, 1, 2, and 3, you can actually store it as each of the values of the enum.
Right. But the thing is, so once we start with number 8, then it means that you are moving this way, and how you're gonna move this way, like, diagonally.
Yeah, you need to move down. Once you reach the 0, 8 at the very end of the first row, you're gonna consider the first element of the second row, the 49.
Oh, okay,
So you're gonna parse row wise and then column wise. I guess column wise first. You're gonna check all the different columns of the first row and then move to the second row. And then you're kind of reading it like characters or words in a book. And for each one of those, you're gonna consider 4 things. It seems like a lot of work, but to a computer, it is not. So here's how I'm going to read in the numbers. So this generalizes to sizes that aren't 20 by 20. I'm just making these static constants for the class. And that way I don't have to go change this everywhere that this is in my code. If for some reason I wanted to check a 10 by 10 grid or a 100 by 100 grid, I would just have individual places, 2 places to change it in my code. And then it would propagate to everywhere else in the code that's going to assume that the size of this structure. In general, good practice. Try to remove constants from your code wherever possible. In this case, the constant 20 would be appearing everywhere. Instead, we should just factor it out into one place where if we need to change it, we can. Since next int ignores lines and we're not switching between ints and other structures, we can just go read the int, read the int, read the int, read the int. We don't need to worry about the entire line structure. The loop structure of num rows and num columns is going to be handling that for us. Since we basically said this is a 20 by 20 grid, when we reach the end of the first grid, we're going to be wrapping around the outer loop once and moving on to the next row. So this will work. If we want to write a tester for this, then we can do something like call this toString. So let's make a method for that. So since there's no like toString of an int array, we're gonna need to come up with the structure for this ourselves. So we can just continue to do this very similar logic, but instead of using num rows and num calls now, we should do something about the grids. We can do grid dot length here, and we can do grid of 0 dot length here. And this does not make any assumption about the size of the grid. There is such a thing called a jagged array that exists in computer science, but Java does not allow it, where each of the different rows of a two-dimensional array can be of different length. C++, for instance, allows this, Java does not. So you can make an assumption if you have a 2D array in Java that at least all of the rows are the same length. So because of this, we just say, however long the first row is, that's how long all of the rows are going to be. That's how many columns we need to go through for each row. So we are here going to print out the value of grid of ij plus a space, because it doesn't really matter if an extra stray space happens at the end of this. And rather than print line it, we want to print it because we don't want a line in between each number. We want to print these all in the same row within the same row. And then between each row and column, we want to print a blank line. Now we want to print the new line. Does that make sense? We're printing each number for each column within a row. And then when we reach the end of that inner loop, we've reached the end of that row. So we want to print the new line that moves us to the next line so we can print the next ones on that. So by the time this is done here, we should be able to call print grid and make sure that we've stored this internally correctly. So we call print grid on nums. Static. That's what I've messed up. And now we run this code and we see that we get something that looks really ugly. Do we buy rather than just printing grid of I, we can do a specific kind of print that is going to do this for us. We can use a printf rather than a print, and this allows us to kind of codify our print to take as many things here as we need. So we can say we want to print, instead of printing this, let's print. Have people used printf before in Java?
Yeah, immediately, zero.
Yeah.
210.
So what variable type do we have underneath the hood here? It's an int. So we want to print out an integer. So %d gives us a decimal integer. That's how I think of %d, decimal integer. Now we want to print it in how many characters? 2 characters? Followed by a space? Now we just have to specify what the integer is, and now this is where we put grid of ij. So this is gonna force everything to take up 2 characters. So even if we see the 4, it's going to be pushed to the back of a space. So we're not gonna see 0, 4, but we will see the 4 printed on the right side of this. If we wanted to see it on the left side instead, how would we do that?
Was it? Just to the left.
We put a negative right here, just to say left align the result. So since we want to right align it, we don't want that. We don't want that, but this is kind of a codify version of that. So now if we run this code, we see that we actually have a grid with the zeros removed from the single digit numbers. So now it at least aligns with itself, so we can see the result. Any questions about using the printf and how that changes and makes it much clearer which numbers are where in our grid? This is just saying print an integer followed by a space, but that integer is going to take two characters regardless of its size. So if we see a single digit, we're going to print a space followed by the digit, rather than just the digit. So we're saying every integer that's printed is going to take 2 spaces, and we're going to right align that number within that 2 character window. So if it's 1 character, it'll be space number rather than number space. And if we did that, if we did the negative here, we would see in fact that now these single digits are left aligned. And now the 8 appears, for instance, here on the left instead of being on the right where it was without the negative. We want it right. I think that is a little bit clearer to see. If you prefer it on the left, you're welcome to throw the negative in there and make it on the left. This is just though to verify that we read in the grid correctly, which we now have. We haven't used the file anywhere in our print grid. We only used the 2D array that we made from reading in the file. So now we know that it's stored internally correctly. So let's go find that maximum value. Keep working on that for a bit, and I will also work on it, and we'll compare our solutions. Myself doing a lot of copying and pasting of code that probably says I should do something about that. What do we think I should do about that? Factor it into a method somewhere? Which means that maybe we should make these global and globally modifiable. That's usually bad design. You want to pass and return. So maybe we want to turn this into an array structure that we pass by reference. I'll let people figure out how to make this clean. But I think this will work. Except that in this case, direction is 1, we'll call this direction 0, 1, 2, and 3.
It's not the direction as a char string.
String would probably be even better. We'll do that. Let's make a string. That's the right answer. So if we go back to our numbers, we know it's 15.3. This is row
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Column 0, 1, 2, 3. Should be, is that wrong? The answer's right here. It should be down left, but we should be finding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0, 1, 2, 3, 4, 5, 6.
should be 12.6. That's something. It is time to go. I will find this bug. But this is the general solution approach. We should probably factor this out and make this cleaner. If I just submitted this, I would be very unhappy with myself. I want to make sure that I did some. But this is the logic you should use. So that's when the types don't match. Which line is it on? So yeah, you're trying to store in grid, but type is grid. In row.
So bad. Yes, so bad. But I did all my lots. And it, because it was really nice.
Interesting.
Because I complained.
It's not.
Yeah.
Oh, yeah, it's not saying it is a final object. So if you see what I did on the top here, I made a file object. And you did.
Well, actually, it makes sense because that was not Irish. Well, we didn't even find it.
Oh, yeah. That's this.